In this video, we will discuss the equality of functions. Let A and B be two non-empty sets, and let F and G be two functions with the same domain A and the same codomain B. We say that F is equal to G when F of A is equal to G of A for all elements little a in the domain capital A, in which case we write F is equal to G. Otherwise, we write F is not equal to G. In other words, two functions are equal when they output the same value for the same input value. The functions f and g may have different formulas or algebraic expressions, but as long as their outputs are the same for the same input values, we say that they are equal. For example, let f be a function from z6 to z6, given by f of a is equal to a cubed mod 6, and let g be a function from z6 to z6, given by g of a is equal to a. Since the domain and codomains for both of these functions are the same, to determine if these two functions are equal or not, we need to compute the images for each value in the domain under both functions, and then compare the results. After computing the images for each element in the domain for both functions, we see that the output values are the same for each input value. So we say that f and g are equal. Now we'll show an example of two functions that are not equal. Let f be a function from z5 to z5, given by f of a equals a, and g be a function from z5 to z5, given by g of a is equal to a squared mod 5. Remember that for two functions to be equal, their output values must be the same for all input values in the domain, not just a few. The images for 0 and 1 under the functions f and g are the same. However, the images for 2, 3, and 4 under f and g are not the same. Since the output values for f and g do not agree at all input values, we say that f and g are not equal.
This next example serves two purposes. We will be given two functions f and g, and we will use the graphs of f and g to see that these functions are actually equal. As we saw in a previous slide, we can compute the graph of a function by evaluating that function at every value in its domain. Let f and g be functions from z5 to z5, where f is defined as x plus 1 mod 5 and g is defined as x minus 4 mod 5. By evaluating f at 0 through 4, I obtain the following values. To get its graph, I will draw my axes like I've done before, I will make a grid, and I will start filling out all of the corresponding values. That is, since f evaluated at 0 was equal to 1, I would fill out the square 0, 1. Since f evaluated at 1 was equal to 2, I would fill out the square 1, 2, and so on. I will repeat this process for the function g. Here is the following set of inputs and outputs for g, and just like before, I will graph it in the exact same way. F and g are functions that are defined differently. With f, I add 1 to each input, and with g, I subtract 4 from each input. But even though the arithmetic is different, the graphs of the functions are the same. This tells me that f and g are actually equal as functions.